Hello and welcome to Nikolay's genetics lessons, and today's problem is find inbreeding coefficient of individual O. And here is individual O, that is our proband, for whom we have to calculate inbreeding coefficient. And as you see, today's pedigree going to be more complex than we seen before. So this is going to be a new level of complexity for us. Let me start with drawing what we see here as a normal pedigree that you usually see in the textbooks. So we have individual A and B here on the top. So let's say here we have individual A and B. Let's say individual A would be female and B would be male. So we have a mate here, and this couple has two children, D and E. To each of these children, of course, each parent contributed 50% of the genes, and we see it that two lines come to every child from every parent. And in this diagram, this would be represented as two children here. Let's say both children would be of the same sex, would be sisters, and as you see, these two people also has children, and C would be a husband of D, and F would be a husband of individual E. So this is going to be individual D here and E here. Both of them has husbands, F and C here, and both of them has also children, G and H. So child G here, so have to be different sex, because as you see, these two children of these parents mate and has their own children. So this is going to be consanguineous mating here, and we use double line here to designate that this is consanguineous mating between two close relatives, and this is going to be siblings, and this is going to be first cousins mating. So this is individual G and H here, and this couple has two children. So one child is say a boy, another also can be a boy, and J and K. Now we see that both of them married, and I and L individuals here, and in each family they have a child M. So this can be a male child, and N, which is have to be female child, because as you see, these two parents also contribute 50% of the genetic makeup and have child O. So we connect these people with double line, because these people are also relatives. And this is going to be individual M and individual N here, and they have child O. Sex is not specified here, but let's say this is female, and now we have to find what is the inbreeding coefficient for this female. And in this video I want to use a formula that you saw before, but it's going to be slightly modified, and here's the formula. F of O, inbreeding coefficient of individual O, would equal to sigma 1/2 in the power of n plus 1. As you remember, in my previous videos that I show you, I put only n here without +1, and sometimes we even don't need sigma here when we have a simple pedigree. But today this is going to be our formula, and as you remember, in some cases we also need second part of the formula. I will use different color for this part of the formula because we are not going to use it today, but I want you to know this part of the formula because in many complex pedigrees like this we have to use it, but this is not the case today. So this part of the formula would be 1 plus 0.0, and this part of the calculation stands for such cases when in a loop one of the common ancestor would be inbred. And as you remember, we had two consanguineous matings here between two first cousins here, and here's going to be another one. But actually, I will demonstrate you in a couple minutes that we don't have here none of the ancestors, common ancestors, that is inbred actually. So let me now explain why we are going to use n+1 today. And there are two ways how we can do calculations. First, we can consider our proband O and do all the passes from common relatives, starting from this individual and ending with this individual. Another way to do our calculations, we can start with parental generation of individual who is inbred and do all our calculations starting from one parent and ending with a second parent, and this variant exactly described here. And today we are going to do all our calculations starting with one parent and ending with another parent. But all the numbers that we are going to get going to be the same. It just would save us a little bit of time. And just take a look what would happen if I would simplify this pedigree, and we would have only this part left. Now it is much easier for you. This is something that you can solve if you watch my previous videos. So we have one parent here, so let's say this is going to be a male parent here and female parent here. So how inbred this person would be if we would see a pedigree like this. We have to do our calculations in certain steps. The first step would be to ask who is the parents of the inbred individual, and this is parents, male parent, female parent. And now second question we have to ask ourselves, who is going to be common ancestors of parent M and N. And now it is obvious that common ancestors would be individual G and H. G would be, if it is going to be, say, male and female here, would be grandparent of M, would be grandparent of N, and individual H also would be grandmother of M and grandmother of N. So this is two common ancestors. As you remember, inbreeding means that we have to find probability for individual O to have two same alleles inherited from the same individual, his ancestor. In this pedigree, it can be with the individual G or H. For example, if G would have alleles A1, A2, and individual H would have alleles A3, A4, we can do following calculations. We have to find number of the passes 1, 2, 3, 4, 5, 6. This is probability that individual O would inherit both from his father side and from his mother side allele A1. 1, 2, 3, 4, 5, 6. So 1/2 each time. We have to put 1/2 here for each pass. 1/2 in the power of 6. Then we have to add another probability that individual O would inherit A2 allele. Once again, this is going to be 1/2 in the power of 6. So probability for this individual to be homozygous for either A1 or A2 allele in this loop would be 1/2 in the power of 6 plus 1/2 in the power of 6. So this would equal to 1/2 in the power of 5, or would equal to 1 over 32. But let's, instead of counting number of passes twice here, then twice here, let's simplify our calculations, and we can say let's count number of passes between two parents. So this is going to be 1, 2, 3, and 4, and would stop our calculations on parents. But in this case, we have to add 1 to number of connections between parents and common ancestor. Otherwise, we would have here 1/2 in the power of 4. But as you remember, we have found that we have to use here 1/2 in the power of 5. This is the same as 1/2 in the power of 6 plus 1/2 in the power of 6. So, because we are going to stop our calculations here on the parents of this individual, we have to add 1 here to number of passes. So let's find what would be inbreeding coefficient for this loop. So this is going to be 1/2. So this is going to be parent G, and we are going to have here 1/2 in the power of 4 plus 1, so in the power of 5, and we are going to get here 1/32. And as for the second parent, H, we're also going to have here 1, 2, 3, 4 passes. So H would equal to 1/2 in the power of 4 plus 1, which would equal also to 1/32. And as you see, if this is going to be our pedigree today, now the next step would be just to add these two probabilities. Here sigma stands for sum of probabilities, so we have to sum these probabilities, and would be our answer that inbreeding coefficient of this person is 1/16. But now let's return to our full pedigree, and once again let's ask the same question: who also in this pedigree going to be common ancestors of parents of individual O? And as you see, other common ancestors except G and H would be A and B. So once again, let's say this is going to be a male and this is female, and let me use this time different colors. Our pathway would be 1 would be 1, 2, 3, 4, 5, 6, 7, 8. So this individual A on top, if he would have, say, also allele A5 and A6 here, the probability that he would pass A5 allele to his great grandchild and this is going to be 1 half, 1 half, 1 half, 1 half, and 1 half. That this would happen through his father side, and also the same probability would be that this would happen through his mother side. And as you see, today we stop our calculations here. So this is going to be how many passes? 1, 2, 3, 4, 5, 6, 7, 8 plus 1. So we are going to get 9. So for individual A, our calculations would be 1 half in the power of 8 plus 1, and we are going to get here 1 over 512. But this is not the only way how the same allele can be passed through all these direct ancestors of the individual O. So here's another variant. This allele A5 would be inherited by individual D, then would be passed to individual G, then would be passed to this child of G, and then would come down to individual N. And another shoulder, another branch would be A, E, E, H, from H to J, and J to M. So as you see, there's two ways how this can happen. So we have to calculate this probability also, which is going to be the same. 1 half in the power of 8 plus 1, so would give us 1 over 512. And the same two variants would be for the individual B. For example, if his genotype would be A7 and A8, we also would have the same two variants, like in this case with this parent, that alleles would be passed directly and with changing of branches here. So two variants. So for individual B, we also have 1 half raised 8 plus 1, which would equal to 1 over 512, and the second loop would be the same, 1 half in the power of 8 plus 1, and would be also 1 over 512. So now we have all the variants how this child can be homozygous, whether for alleles A1, A2, A3, A4, or A5, A6, or A7, A8. Now we just have to add all these probabilities that we got. So we have here 1, 2, 3, 4, 5, 6 loops. So this is going to be first one, second, third, fourth, and fifth, and sixth. And total inbreeding coefficient would be, so if we divide 1 by 32, we are going to get 0.03125. The same number is here, 0.03125. And now if we divide 1 by 512, and if we multiply this number by 4, we are going to get 0.007 7, 81, 25. And now we have to add all these probabilities, and the final answer would be 0.070 31 25, and this is going to be inbreeding coefficient of individual O. If we need an answer in percentage form, we just have to move this decimal point 2 places to the right or multiply this number by 100, and our final answer would be inbreeding coefficient of the individual O would be 7%. And once again, sigma stands that we have to add all the probabilities here if we would have more than one loop, more than one variant of the path. And why we didn't use this part of the formula, I just want one more time to show you that we don't have any common ancestors here who is inbred. So once again, here our picture that we start initially, and his parents of individual O. Once again, who is going to be common ancestors? Common ancestors would be individual G and H. And now question, does individual G is inbred? Here we see two parents, both of them has two children who are siblings. Those children married to unrelated people, so G and H are not inbred. And another loop, we had here individual A and individual B, and of course these two individuals also are not inbred. That's why we didn't use this part of the formula when one of the common ancestors would be inbred. And the only people here in this whole pedigree that is inbred would be individual J and K, and individual J and K are not common ancestors of the parents of individual O. Individual J would be ancestor of the individual M, but wouldn't be ancestor of the individual N. Would be genetically related, would be relative, but wouldn't pass any of alleles to individual N. Let's say this is going to be a male, this is going to be, say, female here. So this individual would be a father of individual M, would be an uncle of individual N, and uncle, those is a close relative. Those J and N would share some of their genes, they would be genetically related, but uncle doesn't pass any genes to its niece. So genes come from her mother and her father. And the same picture is here. Individual K, who is going to be inbred, would be an aunt of the individual M, parent of the individual O, would be related to this individual because she's going to be an aunt. And she doesn't pass her genes to individual M. Only individual J pass, individual I pass, and all the direct relatives pass in this pathway. And as we said, it can be this pathway. So those we have here inbred individuals, but we do not include them in our calculations, because these individuals are not going to be common ancestors of both parents of individual O. Only G and H would be, and these individuals are not inbred, and A and B, once again, these individuals are not inbred. I hope my explanation were clear enough. Now you would be able to solve analogous problems, and now I hope different variants of the formula that you may find in the textbooks wouldn't be a confusion for you. and you would understand what each letter here stands for, why we have sometimes here n, sometimes n plus 1, sometimes we even may have n minus 1, what this part of the formula for, and when we use this part of the formula. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.